Okay, so here we are looking at Algebra 8-2, arithmetic sequences. So here we are to identify which sequences are arithmetic, find the common difference, fill in the blanks, create an equation, and find the 10th term. Woof. A lot of stuff. So keeping in mind that arithmetic means that there is a constant rate of change, which means that we are adding or subtracting by the same amount each time. So that's what I'm looking for. So arithmetic is that adding or subtracting. That's CROC, that constant rate of change or that common difference. So in this first one here, to get from 2 to 4, I need to add 2. And to get from 4 to 8, I need to add 4. And I can immediately see that that is not what's going on here and that this is not arithmetic. So I'm just going to, make that a point. This is not arithmetic because it doesn't have a constant rate of change. It doesn't have a common difference. Any one of those things would be fine. It doesn't have a constant rate of change. Maybe you noticed that it does have a multiplying factor though, right? Maybe you noticed that each time you're multiplying by 2. You can say that instead, that there's a multiplying factor. There's a multiplying factor of 2, but that doesn't make it's arithmetic. So that's the problem there. Okay, moving on to B here. I've got 50, I've got a blank, 40, 35, 30. So looking there, I've got from 40 to 35, I've got a minus 5. Oh, okay. Minus 5. Minus 5. So therefore, this missing term here has to be 45. And then this would be arithmetic because, again, it has a common difference of that constant rate of change, that minusing 5 each time. So this is arithmetic because it has a constant, I'm going to abbreviate this from now on, a constant rate of change of minus 5. Okay, so that minus 5 right there, that's my common difference, aka my D value. Right, because we just learned that we're going to be using D as our variable for common difference now. You wouldn't be wrong to use M. M is still the slope. It's still the same thing, just different problems. Okay, so we filled in the blanks. We need to create an equation to represent this here. So an equation. This is arithmetic. Arithmetic immediately should be going through your head is linear. And when you're thinking linear, the equation that should be going through your head is a y equals mx plus b type equation, where we need the m and the b filled in. So, something to put my feet up on. It's been a long week. So we need the slope and we need that y-intercept. Well, we already have our slope of that d value, that common difference of negative 5. So a of n is going to be equal to negative 5. Instead of x, I'm using n, and now I just need that y-intercept, my b value, that y-intercept. So that y-intercept, remember, like we talked about, is that a sub 0. Here, there's nothing here that would make me think that this is a sub 0, which means that this is a sub 1. So if I need to minus 5 to get to the next term, and we want to work backwards from that, the opposite of minusing 5 would be adding 5. So instead of minusing 5, I'm going to take 50. I'm going to work backwards. Actually, I should go under. Backwards, and I'm going to add 5 to get an a sub 0 of 55. Therefore, my equation is going to be a of n is equal to negative 5n plus 55. And in sequence notation, I would just lower that first n. Everything else stays the same. All right, and last but not least, real quick, finding the 10th term, and I can use my equation for that because that was the whole point of it. Negative 5 times 10 is going to be negative 50, plus 55 is going to leave me with a positive 5 for the 10th term. So a of 10, or a sub 10, is equal to 5. Alrighty, moving onwards to part C here. Part C, we're starting with 1, we're going to 1/5, and then 25, and then 125. So right there, I can see that there's nothing, this isn't going to be arithmetic, because to go from 1 to 1/5, I would have to minus 4/5, and that's not going to work going from 1/5 to 1/25. So definitely not arithmetic. And again, there's no constant rate of change. Bloop, bloop, bloop. And again, we're just going to leave it at that. I mean, if you want to, you can notice maybe that the pattern is just multiplying by 5 on the bottom, technically. And what would I be multiplying by on the top? What times 1 gives me 1? 1. So I'm really just multiplying by 1/5 here. That missing term, if you're dying to know, would be whatever 125 times 5 is, which is 625 over 1. But anyways, we can move on. And then the last sequence we're going to look at is D here. And D is actually a really, really, really famous sequence that some guy came up with or discovered. I don't know, whichever one it is. And so maybe if you want to pause this and take a second and try and figure out the pattern and what this next term would be, might be fun. You might enjoy it. If not, spoiler alert, I'm going to tell you. So this sequence right here is what is known as the Fibonacci sequence. Fibonacci. Fibonacci sequence. And the Fibonacci sequence is neither arithmetic or the sequences that we're going to look at tomorrow are called geometric ones. There's not a common difference. There's no common difference or common ratio, or as you're more familiar with, multiplying factor. So the missing term here would actually be 21, and that's because you are adding the 2 previous terms to get to the next one. You add your 2 previous terms. So here, 1 plus 1 gets me to 2. 2 plus 1 gets me to 3. 2 plus 3 gets me to 5. 5 plus 3 gets me to 8. 8 plus 5 gets me to 13. 13 plus 8 gets me to that 21. So kind of a cool little pattern. Probably do some more research on it if you wanted to learn more, but that's as much as we'll get into it.